Methane is relatively soluble, but when you churn up the water, it'll come out of solution if you mix it with the atmosphere. So anything like a hurricane or a tropical storm that deepens the mixed layer of the surface ocean is going to increase that gas flux.
How much does hurricane deepen the mixed layer?
Well, that's a good question, and the answer is we don't really know, but it certainly doubles or triples its depth. And the other thing it does, we had a series of instruments out at Mississippi Canyon 118 last fall when I think it was Hurricane Ike. There were two hurricanes that went back to back up the slope and almost crossed right over MC 118 and MC 252. And we saw there was about a 2-week period associated with the hurricane where the bottom water temperature, even at 1,000 meters, was altered. And what you could see is as the hurricane pushed up the slope, it pushed cold water up in front of it. And that signature, so even at 1,000 meters, you could see a change in temperature for 2 weeks. And if it's pushing water up the slope and churning water on top, it's certainly not going to mix 1,000-meter water column, but it'll probably mix to the seasonal peak, to the bottom of the pycnocline, where the salinity surface is stable below there, is about 500 meters. So it could probably mix hundreds of meters down, deeper than it usually does.
Dr. Joye, if they're able to put the cap on that they're saying might be finished in August, let's say it happens and all of that is successful, what are we looking at as, that'll kind of be the end of the oil spilling, but then what are we looking at, I guess, kind of what are the repercussions going to be once all the oil, because that would be millions of more barrels of oil that have spilled. So, of course, more gas, more oil. What are we looking at that point?
Well, the question is what happens after the cap goes on in August, assuming the relief well works the first time. There are a couple of issues with this. The first is the flow of oil and gas from this well is only going to be halted if the casing is intact. So you have the surface of the seafloor where the leaking riser pipe is right now, and then there's around 12 to 14,000 feet of casing, and then the reservoir is down here, right? So if you put a cap on here on the top, or you relieve the pressure, and actually it's not a top kill, it's a bottom kill. So what they're going to do is pump cement into the right above the reservoir. So they're not, the top kill, which they tried a few weeks ago, was to cement the top of the well and close it up that way. The bottom kill, which is what the relief wells do, is to close it from the bottom up. Now, that works fine as long as the source of oil and gas, and for oil it's almost certainly true, is the reservoir. A lot of the gas could be coming from the overlying sandstone. So if that casing is intact, the bottom kill will shut off the flow of oil and gas completely. If the casing from the seafloor to the top of the reservoir is not intact, then you can still get gas coming out of that pipe. And we don't know whether that casing is intact. In fact, there's been some speculation that perhaps it isn't, because there's so much gas coming out of the wellhead that it could suggest that there's some fracture in the casing. And that's not unusual under these conditions. It wouldn't be unusual at all for that to happen. But certainly the flow will be reduced orders of magnitude, or at least an order of magnitude, by the bottom kill, assuming it works. But you could still have some gas coming out. So you won't have oil, but you could still have some gas coming out, even if the casing is not totally intact.
And the casing that we're talking about, that's at the well or at the site? Or
no, think about it this way. If this is the seafloor, okay, there's a casing that goes down from the seafloor to the reservoir, which is where my hand is. This pipe right here, this casing, if this is intact, if you seal the well here, then it shuts off the flow. If there's a crack somewhere along here, then gas can get into here and still come out of the top. Does that make sense? So, and it's really the overlying capstone on this reservoir is sandstone that's gas charged. So if there's a crack in that casing, you could still get gas going up the casing and exiting the top at the seafloor, even if the bottom is sealed off. And that's going to keep going as long as there's pressure in the casing.
This could stop the flow of oil, but the flow of gas would could still continue, although at a reduced rate?
If there's a fracture in the casing, and that has been discussed recently because there's been a increase in the gas flux the past couple of weeks, and the suggestion is that could be one idea to explain that is that there's gas coming up the casing, independent of the material that's coming up from the reservoir.
There's been an increase in the gas flux in the last couple of weeks?
The fraction of gas flux. And again, these are it's very, very difficult to separate gas from oil, and this is from the video feed and just looking at the bubbles, and it, there has not been an update from the flow rate technical group on the flow rate. This is all just discussion among people that are working out there that and people who've been watching the video feed, which I do a couple times a day. You can see that there's a lot more. It looks gassier than it used to, and that could be something related to the casing, or it could just be that there's the part of the reservoir that's bleeding out right now is just really gassy. It's just impossible to say. And the reason I am telling you this is because that bottom kill, it could stop everything, but it may not. And if it doesn't, then that's why, most likely. And the bottom kill right now, they're doing this. They got within some distance of the wellhead, and now they're going down, trying to, on a parallel track until they reach the depth where they want to put this top kill plug or bottom kill plug in. And it's.
You talked a little bit earlier about the plumes, and I was wondering if you could update us on the status of those plumes. Are they growing in any fashion, or covering more of the subsea area than they had been, or do we know at this point?
I wish I could tell you. We don't know. Right now, there's a cruise out there staffed mainly by folks from Woods Hole Oceanographic Institution with a bunch of in situ instrumentation, and they're doing plume mapping. They have not released a report to date with updates on size of the plume. But remember, that's one vessel, and there's probably multiple plumes. So it really is going to take a lot more of a coordinated effort to track these things and map them properly.
How could they not be growing?
Pardon?
How could they not be growing?
Oh, they're almost certainly growing. I mean, the only thing that would stop them from growing is if the gas flux stopped, and it hasn't. So they almost certainly are growing. They are flaring off a fraction of the gas now on the drill ship, but they're not flaring off the entire gas flux. The calculations that I've done suggest at most they're flaring off 50% of the gas flux. That's the maximum that they can possibly flare off, is about 50%. And and that the number depends on what the actual flow rate out of the pipe is, and we don't really know that number with a lot of certainty. I can't tell if this is actually working or not. I don't think it is for some reason. The little buttons that usually flash aren't flashing.
Let's see, do we have people on the phone?
Yeah, we're here.
Okay, good. You've been quiet today.
I didn't think it was working. It was so quiet. Was there a question that I interrupted, or it was just my train of consciousness? Any questions on the telephones?
Dr. Joye, this is Matt Brown with the Associated Press.
Hey, Matt.
Hey, on the when you say they're flaring off 50%, at most flaring off 50% of the gas flux, the flux, that's just referring to the gas coming out of the leaking wellhead, right?
Yeah, and that number I come up with by taking the oil flux that is, the high and low numbers of oil flux that comes from the flow rate technical group's report, and calculating the fraction of gas that's associated with that. And then I get the flare rates from BP Minerals Management Surface sources, and you can estimate based on what they're flaring off how much, what fraction that accounts, what fraction that makes up of the total gas flux.